In the song, The 12 Days of Christmas, you get a whole bunch of presents. The first day you get one thing, the second day you get 2 plus 1 things, the third day you get 3 plus 2 plus 1 things, and then the 12th day you get 12 plus 11 plus 10 blah, da, 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 plus 3 plus 2 plus 1 things. So every day you keep getting more and more presents. So how many total presents do you get? So there's the brute force answer, which is to just add up all the numbers. But the elegant solution is to use the hockey puck identity in Pascal's Triangle. So I'm going to show you the elegant way of solving it. Okay, the first day of Christmas, you get a partridge in a pear tree. The second day of Christmas, you get 2 turtle doves plus a partridge in a pear tree. The third day of Christmas, you get 3 French hens, 2 turtle doves, plus a partridge in a pear tree, and so on. The 12th day of Christmas, 12 drummers drumming, 11 pipers piping, 10 lords leaping, and so on, 3 French hens, turtle doves, a partridge in a pear tree. So that's how much we get each day. So the brute force method would be to add up all these numbers. I certainly am not going to do that. I'm a mathematician. I'm going to look for a more elegant solution. So on any given day, let's look at the 12th day here. We're just adding up the numbers from 1 to 12, and we can use little Gauss's formula to do that, which is n times n plus 1 over 2. So I've done that for all the days of Christmas. And n times n plus 1 over 2 is the same thing as n plus 1 choose 2. So we have 13 choose 2. This is from Pascal's Triangle from combinatorics. How many ways can we choose 2 things from 13 things? It turns out the sum of the first n integers is the same thing as that. So we get 1 thing the first day, 3 things the second day, then 6 the third day, 78 presents on the 12th day. So if we were to add all these up, which I certainly did not, I would call that also brute force. A little bit better than adding all these numbers up, but that's 364. The way I got it was from the hockey stick identity of Pascal's Triangle. Here's the hockey stick identity of Pascal's Triangle. First day of Christmas, we get 1 thing, then 3 things, then 6 things, then 10 things. By the time we get to the 12th day of Christmas, we get 78 things. So the hockey stick identity says the sum of the handle of the hockey stick equals the blade of the hockey stick. 364 things, which is a beautiful identity. Now I'll show you the proof. Now I'm going to prove why the hockey stick identity is true. Here's a formal statement of the hockey stick identity, where this long part is the handle of the hockey stick and the sum is the blade of the hockey stick. So what it's saying is you kind of walk down one of these diagonal columns of Pascal's Triangle. So that's the sum, and it's saying the sum is the blade, is this number here. So that's what the hockey stick identity is saying. So now I'm going to prove it by induction. The base case is n choose n equals 1 for any value of n. So the base case is true. Now I'm going to prove it by induction. Suppose it's true for a length n hockey stick. Now let's examine the n plus 1 case. So the n plus 1 case is, suppose we have a little bit, one more number here, and we want to show this sum equals this number here. Okay, well, how do we do that? We know by definition of Pascal's Triangle, we have this bunny ears identity where every number is just the sum of its parents above it. So this red number here is just the sum of these 2 numbers above it. Well, this black number, by the inductive hypothesis, is the sum of all these black numbers in the handle of the hockey stick, plus this red number here, which equals the blade of the red hockey stick, the n plus 1 hockey stick. So very trivially with pictures, we can see that the hockey stick identity is just a consequence of the bunny ears property of Pascal's Triangle. If you're looking to get someone a Christmas present, why don't you get them this nice pie t-shirt? People who like math or math fans, or people who like t-shirts or pie or smoke, or just anybody, just buy this t-shirt. It's my friend's company. The company is Mashed Potato Jones. So I have a link to it in the video. So just go ahead and buy this t-shirt. Anyways, so How many presents were there for the 12 days of Christmas? 364 presents. It's a cubic function of the number of days of Christmas. It's n plus 2 choose 3. So 12 plus 2 choose 3. 14 choose 3 is 364. Get it right this time. Now, if there were 100 days of Christmas, that would be 102 choose 3, which is, off the top of my head, 171,700. So you're lucky there aren't 100 days of Christmas. Now, what if there were 365 days of Christmas? It's a cubic function of 365. 367 choose 3 is, let me do this on my head, 8,171,255. So, Mashed Potato Jones t-shirts. Thank you very much.